Our next presenter is Mr. Harsh Shastri. He is from LD College of Engineering, and his topic is use of robotics for untraditional method of farming for the development of agriculture 4.0, analysis, challenge, and future scope. So over to you, Mr. Harsh.
Okay, so good evening to everyone. Today I'm going to discuss about use of robotics for untraditional method of farming. Basically, it's due to time constraint, we are skipping some of the part of my presentation. So very quickly we will see what is my fact finding, what are the challenges for the untraditional method of farming, and future scope. Also, I will okay. Also, we'll discuss about the future scope and a glimpse about research work which me and my guide, Dr. Manish Thakkar, is pursuing right now. Okay, so these are contents and objective of today's presentation. That traditional farming is about to reach its saturation level. Okay. Also, since the last 2 to 3 years, during the time of a pandemic and a situation like man-made conflict like war and everything, we have learned a clear message that we can't rely on the market for our food need or food demand. Okay, so we have to self-sustainable as well as we have to produce our food by ourselves. Okay, so like the person like me living in the city, it's a very difficult to find agricultural land because the land scarcity is one of the biggest problem. Okay, so it's not possible to become a self-sustainable for my own food demand for me. So if I'm going to use some traditional method of farming, so obviously some of the options like hydroponics, aquaponics, aeroponics, some untraditional method of farming or novel method of farming are there. But even though these methods are not coined as it should be, and what are some of the problems and challenges that we will discuss, and some of the solutions using a robotic or automation based system to meet the future food demand. Okay, so food or agriculture is one of the most important parameter, also most neglected area by the technocrats. Because a hungry man can't find what's right or wrong or what is technically sound or non-technicality. Okay, so food is most crucial and most important parameter. So in the 2015, the United Nations General Assembly was held to achieve to create a blueprint to achieve a better and a more sustainable future for all. Okay, the outcome of this assembly was a 17 interlinked sustainable development goal. Okay, so basically in my presentation, I am focusing on goal number 2, that is a zero hunger. Also, the goals are interlinked. So goal number 3, that is good health and well-being. Goal number 11, that is sustainable city and communities. Also goal number 12, that is responsible consumption and production. Okay, so to achieve these SDG, Sustainable Development Goals, in the 2018 World Government Summit was held, and during that summit, all the nations were agreed to focus on the fourth revolution of agriculture, that is 4.0. Okay, so in this revolution, we have to incorporate all the industrial technologies and novel innovation, which we are only focusing for the industry. We have to apply that technology to the agriculture. Okay, so some novel method of a farming like a vertical farming. Another is a hydroponics. Instead of a soil, in some water or inside some water. Another technology is aeroponics. that the plant is hanging and its root has been placed in some closed container, and we are spraying water with some fertilizer on its roots. Another technology is aquaponics. So aquaponics is a hydroponics plus having some farming. So whatever the byproduct of the fish or biological waste of the fish will work as a fertilizer for your hydroponic farm. Okay, so that hydroponic farm or your plant will absorb that byproduct like ammonia and all that. It will work as a fertilizer for this plant, and it will get some purification of that water, and again that water to uh, send to our fish tank. Okay, so this is a closed loop where aquaponics, where fish tank and hydroponics both thing can work together. Another area of a novel method of a farming like a seawater farming, underwater farming, space and so as I was saying that now it's a time to move towards some novel method of a farming. So like a farm inside our factory, farm inside my home, farm inside the office, hotel or empty container. So what we have to do, we have to identify, just a minute. Okay, so we have to identify some best technology or best methodology, and we have to apply it to the plant while simulating carefully controlled grown condition in a closed structure. Okay, so Fujitsu Aerofarm are some of the big giant company who is doing very well in this area. And Japan, North America, China, UAE are some of the key players for these vertical farming or farm inside the factory or farming factories. Okay, so in the UAE, the world's biggest indoor farm is under construction, and very soon the country which is having some majority part is a desert, and it depends on the import of food from other countries. This country will in the future will be capable to export the food. Some of the advantages of this method of farming, we require less water, less soil, less fertilizer, etc. Talking about less, so some research says that the less part is a 90% less. Okay, so that means in a normal irrigation system, only 10% water get utilized by the plant, remaining 90% water either absorbed by the soil or got evaporated. Okay. So what are the challenges? The biggest challenge that the farming or agriculture has lost its grammar to attract generation. Okay. Lack of a time and the skill, another biggest challenge. And the precise control of a parameter and environment. Definitely it needs some investment. Economical and ecological solutions are very rare. Okay, so with help of robotics, we can solve this some of the challenges. Like we can bring back the charm of a farming, optimize control and parameter, and everything is there. Okay, some of the challenges for hydroponics and advanced light system, because what happens in this hydroponics based vertical farming, that we are having a stacks of plants. So we require advanced lighting system to grow each plant. Okay. Some automation technologies are required, and the dedicated robotic system to monitoring and harvesting of this farming. If we are using aquaponics, then along with all these challenges, some new challenges has been added, that to continuously monitor and control the ammonia, pH, oxygen, other nutrition levels. Okay, so there are two terms. First is a robot, machine, or a automation system. So by definition, an automation system is something like what dictionary says, that the system which is monitoring and controlling or doing some repetitive task inside a factory, while the robotics is a machine that labor task. Okay, but upgradation of a technology, these both term has been very nicely overlapped each other. So it's a very difficult nowadays to distinguish that, okay, where is the robotic part finishes and automation starts. So automation robotics are uh, something like that we can't. Some technologies, many of my fellow already discussed, so I'm skipping this part. GPS, vision-based, sensor-based robotics can be used for field analysis, plantings, crop spraying, artificial sensor technology can be used for monitoring various parameters, and nanotechnologies. So the nanotechnologies, encapsulated fertilizer, pesticide can be used to release the fertilizer as per the need of the plant. Okay, some nano-based biosensor uh, are also in the trends right now. So one of the example is a stem sense. Okay, so stem sense is a sensor that measures the stem water potential inside the plant. Okay, so what is our normal approach? If we are just visualizing what is the condition of a land, if it's dry, we start flowing the water, we start our irrigation system. But we don't ask the plant that what is your requirement. Okay, so this sensor having some non-invasive method which continuously measure the water potential inside the plant, and based on the feedback of that sensor, we can start or stop or control our irrigation. uh, some of the research which is going, so about the plant communication, so plant can communicate through the chemicals. So terpenoids, which are compound of 22,000 chemicals. So plant can communicate with each other with this kind of chemical. Also, University Nanyang of Singapore, they have established communication through electrical signal to and fro from the fly trap plant. Also, Israel identify that plant can emit some informative airborne sound when they are under stress. The researcher from the Pakistan, they've identified that if we target some sound wave to the plant, then we can affect the growth of the plant. Also, dedicated sound frequency can increase the stress tolerance of the plant. So up to now, we are focusing. We are just focusing on to optimize our resources and everything. But if we are going to develop a robotic system, then system should be capable to communicate with the plant with this kind of research. Okay, so maybe possible if I'm having some system, robotic system to take care of some terrace garden at my home, and if it's not having a water for certain days, and be produce some sound waves, so the stress response of the plant should minimize. Okay, vision-based system and artificial lighting system. Again, it's a very important. Uh, Again, artificial lighting motion control system. Again, it's a very important for plant growth. So with help of artificial lighting, we can modify the biological clock of the plant. So whatever the production, suppose we are getting in the 60 days, if we using some artificial lighting inside some closed chamber, then we can get our production some more quickly. Okay, so what is the future scope? First thing is that we are not having any dedicated simulator for to understand uh, what would be the response or productivity of the plant. Okay, so on this area, me and my guide, Dr. Manish Sekar, is working. So what we are doing is doing we are we are trying to make some platform, something like this, and we are having a target that to identify what is the best value of a temperature or a pH for a plant to irrigate. Okay, so for irrigation water, what is the best value of a temperature and pH. So P1, P2, or P5 up to P45. So these are our plant. So on the first row, we are maintaining the temperature 25 degrees centigrade, second row 26 degrees centigrade, and so on. Same way, first column, the pH is a 6, second column pH is 6.5, pH is 7, and so on. Using some vision system, we are continuously monitoring the growth of the plant, and for a certain period of a time, maybe from weeks to months, we are carefully controlling this platform through some automation techniques like a PLC and SCADA, and vision monitoring system. Using vision monitoring, we identify that if this plant growth is a maximum, then we can identify, okay, for a particular this family of a plant, the most suitable temperature is 28 degrees centigrade and the pH of a water should be 7.5. This is just a two I explained for easy understanding. There are a minimum 15 parameters that we have to look and control. Also, this system can be used to establish a relationship between the plant growth and applying a methodology. Okay. So if I identify that, yes, my temperature is 28 degree. So in next phase or next experiment setup, what I will do, I will apply temperature of water 28 degrees centigrade with 7.5 pH. And on the first row, I will provide 100 ml, another 125 ml, and so on. Okay. So again, I will identify, I will monitor the growth of every plant, and I will identify the best grown plant, and this way I can identify the quantity of water, the best quantity of water, the time. Also, we can change the duration of irrigation. So maybe possible for the first, we are using once a day, and in the second, we can have a 50 ml twice a day, third 33 ml thrice a day, something like that. So using this platform, we can simulate a various condition on the plant, and based on that, we can have some standard set point which we can give to our robot, and based on that, we can design our system. Okay, sorry.
Thank you very much for your presentation. So from audience, if you have any question, kindly you may ask.
Hello.
Yes.
Dr. Shastri, this is Mahendra here.
Okay.
I have one question.
Yes, sir.
That you have, as you showed the table, and you have multiple parameters.
Okay.
So when the number of parameters increases, as you mentioned that there are around 15 parameters,
Okay.
then there is a lot of interdependency. Then how you identify that, which means how you do the predictive analysis in that one?
So definitely that part has to be worked out, because talking about the TRL level, and current my stage is between a TRL 2 to 3. So till now the prototype has not been actuated, but definitely we have to think on it. So what we are targeting that establish a relationship between 2 to 4 parameter, and then step by step we are going to increase one by one parameters.
Okay. Any specific predictive algorithm you are trying right now, or means it's just an experimentation?
Yes, sir. This is basically an experimental setup right now. So once we are getting some data, then we can establish some relationship between parameter variables with the growth of the plant. And when that relationship we can identify, then based on that we can select that, okay, this algorithm will work or no.
Okay. 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 Thank you.
Okay. So I again thank you, Mr. Hirsch, for presenting a nice presentation. And of course, other people can reach to Mr. Hirsch through emails if you have any further questions. So we will move on to our.
Something has been left. So these are some of the references I used. And while making a robot and while working the robotic system, I wish that we all have to think about some of the factors, that what will happen to my robot after 500 years. Okay, so after lifespan of our system completes, then whether we are just converting our beautiful earth into a junkyard, is our robot is for fun, luxury, additional facility, or necessity? Is our robotics are affecting the employability, especially in the low income society? And is our robot is killing the human skills? Okay, so those are working in this field. So also we have to think about these questions. Okay, so here I'm ending. Yes, Mr. Man.
Thank you, Mr. Hirsch.